In this video, I want to give you a brief introduction to the Monte Carlo simulation and the Latin hypercube sampling. So here I have a normal distribution, a mean of 0, standard deviation of 10, and this is the cumulative distribution view of it. I have partitioned it into 5 sections. The 20% of the numbers are here, 20% fall in here, 20 in here, 20 in here, and then 20 in here. And if I was taking a sample of 5 using the Monte Carlo process, I could conceivably get these 5 data points. So these 5 data points come from a relatively small part of the curve between 20% and 60%. Okay? Now, if I had a Latin hypercube, the way Latin hypercube works is it says if I have a sample of 5, I'm going to divide my number line into 5 equal probability segments. Each segment has 20% of all the values in it. And then because there are 5, it intentionally assures that I get 1 from the first segment, 1 from the second, 1 from the third, 1 from the fourth, 1 from the fifth. So these 5 numbers would better describe the actual distribution than these 5 numbers do. So when you have a small sample, Latin hypercube gives you a more efficient sampling method. If I had 10 samples, then this would divide the distribution into 10%. 10, 20, 30, 40, 50, 60, etc. And if I had 10 Monte Carlo samples, well, actually the Monte Carlo doesn't even divide this into segments. It just randomly takes 10 samples from wherever they would come from. But once you get up into the thousands of numbers, then chance has made sure that you have covered the entire number line here, whether you're using Monte Carlo or Latin hypercube. So unless you've got a particular reason for doing so, just use Latin hypercube.